Hi guys, and good afternoon. Today I've started kind of working on a black and white. This is a Motorola XM-701, I believe, the 23-inch black and white. And I'm going to show you how I've gone about replacing the caps. Instead of using a replacement or whatever, I like to solder a couple terminal strips onto the chassis and then attach my caps that way, and I'll show that to you. I've just finished capping this one and it looks really good, so let me show you what that looks like. Okay. Here you see I have two terminal strips soldered onto the chassis. The chassis is ground, the frame. And I replaced this socket. Didn't look very good, so I replaced that socket, and I've recapped. This is the 470 and the 22 at 250, I believe. And then down here I have the 680 at 100 and the small one, the 220 at 50 volts. And yeah, you can see I have the center is ground. And you can see where I have two bus bars going from this ground right here. Let me get something to point with. Okay. You can see down in here I have this connected to the center and this connected to the center. You can see that. So this is ground, and it's soldered to the chassis ground. That's, I have two terminal strips for 4 caps. And I did the same thing up here with this one. I have the two centers soldered to here, and then this soldered to the chassis. And then my 2 caps soldered to those leads there. And I just ran the wires corresponding, to the caps there. And this, in the future, going forward, and I got this resistor here, across these 2 caps, as it is in the schematic. But going forward into the future, it'll be easy to replace these caps. All you have to do is desolder them from the top of the terminal, because all the other soldering, the wires are soldered into the bottom hole of the terminal. Yeah. That's kind of how I like to do it. So I got it recapped now. It looks like this had been recapped, so I'm gonna put this thing down and give it a try and see what happens. At least I'm gonna plug it in and make sure that it actually kind of looks like it's working, So let me do that. Okay, here's this thing. It's plugged in right now. I just kind of have that dangling off to the side there. You can see the caps are visible there, and there's one right there. And you can see where I replaced the insulator on that guy. I tested all the transistors and they were all good. So this thing is actually, it's on right now. No fuses blowing. So I guess the next thing to do is just hook it up to a tube and see what happens. I've got an Atari football board that I can hook up to it, and we'll see if we get a picture. Alright, we're working on this. I got it hooked up, obviously, you can see. And what's going on is I got no high voltage. And I've checked and made sure the wires on the high voltage transformer are all intact. And they are. That seems fine. Let me go ahead and kind of do this. And do I need to zoom? Yeah, okay. Yeah, we're working around in this little area here. Actually, the whole area, I guess. I got my schematics and all information for this printed up. Okay. And what I'm going to have to be doing here is checking the horizontal drive and all that. And so let me kind of get situated to what I'm going to be looking for and everything, and I'll come back once it's a little more clear of what we're looking at. I got to look over this circuitry a little bit because I haven't really gone over it at all. But our caps look good. That looks really good. Yeah. Alright, I'll be back. Okay, I did some quick poking around. I actually put a known good from my black and white monitor. I put the deflection, the video board on this thing just to see if there was just an easy swap tactic, and Swaparooski didn't make no difference. Still the same. And I was like, well, let me just start with the power supply. Or I was messing around, poking around the sync separator is what I was doing, because I've got most of my voltages and everything, but I don't believe that this transformer is bad because there's no burned up on it. All of the leads are there that solder into this. So I'm not assuming that that is bad. I'm assuming that that's good, actually, because it looks good. So I got to poking around the sync separator circuit here, and I noticed where it says 30 volts down here. That's on the basically that is on the collector of Q5, which is right here. And I probed on the collector of, and now granted there's a 27k resistor in line here, you know, so I should have still some voltage. It says 1.2 volts and I didn't have any voltage there. So I got to poking around and looking at that 30 volts, and I tracked that back to the power supply. This 30 volt B plus right here. Right there. It's on the, you can see it's on the positive of the 220 microfarad cap. Right here. The 220 microfarad cap is the little guy. It's a 50 volt cap. It's this guy right here. And when I probe this, I have like 1 volt. But this is a 1.K resistor right here, 5 watt. And you see on the schematic here, it says these are your two caps. You have your 73 volts B plus right here on this 600 microfarad cap. Then it goes through the 1.2K resistor to drop it down to 30 volts. Now, when I read across that guy in ohms mode, if I put that right there, maybe let's try to zoom in on that guy a little bit, right? Okay, and I'll read across that 1.2K resistor. If I just read across it, I get Well, actually, yeah, now it's reading right. It wasn't before, so false alarm. That seems to be okay. Actually, it was hot. It was really hot when I tested it. So here's what I'm going to do. Let's test it, and we'll see. Come on. Let's do this. Let's get on this joint. Right? And on this joint right here. Yeah, it's right around 1K, which is fine. Now what I want to do is I want to plug it in, and we'll turn it on and heat it up and see if that resistor, we'll see what this resistor's value does. So let me go ahead and turn it on. Sorry. All right. Now it's turned on, and I'm going to let that resistor just kind of cook and heat up. Yeah. See, we can go and test our other voltages on the power supply. At the cap of the 600 microfarad, we got 73 volts. And 65, that should be okay. Okay, this should be, this one right here should be that 70 volts or whatever. Ooh, that one's got 123. Oh yeah. Yeah, that's right into the regulator. This one we have that regular B plus voltage. What we're missing is this B plus voltage. See, that's supposed to be 30 volts, and it is 1.7 volts. Now, I want to turn it off and read the resistance across that resistor right there. So let's do that now. Let's go ahead and turn it off. Now we are off. So I will grab onto this without shorting it, and then go across to here. Yeah, see that? It's at basically 500,000 ohms. And it just went back to normal. See, that's very strange. Yeah, this thing's acting really strange. And one more time for good measure, I'm going to fire it up, turn it on. I'm going to go ahead and turn it off again and measure across there. Yeah, see, it's going into the mega ohms and then dropping. See that? I don't know if that's because of the circuit that it's in. I could remove this board. Let's do that. Let's do that. Let's remove the board. Let's just remove this, because that'll take that out of circuit. I hate removing these. Okay, just remove that, get it out of the circuit. Now with that removed, we're isolating this because that goes up to that looks like it's going up to, I don't know, and then the plus 30 goes directly to there and to one of these pots. Yeah, that one's going to horizontal hold. So you're adjusting the horizontal hold with that. Strange. Anyway, let's go ahead and check what our ohms are. Probably right where they should be. Yeah. About 1.13 ohms. And let's turn it on. And we're back up to that 12 mega ohms. Which there's two caps there, so I don't know. Yeah, let's go ahead and turn it off. Yeah, and the mega ohms. See that? I don't know if that's just because it's hooked to caps though. And it seems like it would take the path of least resistance through the resistor and give me that. I don't know. Anyway, I'm going to remove that thing and replace it. As I do have another one over there, and it's going to smoke because it's got freaking hot glue on it. So it's going to smoke a little bit and burn that off. I'll try to chip as much of it off as I can. But yeah, so this resistor seems kind of funny to me, and it's kind of you know, I'm missing my 30 volt B plus, so it's not going to work without the power supply working. So you go ahead and do all that. I'm going to remove this guy, pop a new one in there, or come up with a different. Maybe I have a direct replacement. I don't know. We'll see. I'll be back. Okay. What I have kind of found, I think I damaged this capacitor right here. And I think that it is giving, I think it's shorted, I think it's internally bad. Let's put it that way. Possibly, because I changed the resistor and I'm getting the same thing really. So it wasn't the resistor. But now I'm thinking back, and now I understand more about this circuit now. The regulator, okay, let's go over the schematic here. The regulator, this guy, let me get my pointer. The regulator driver, this guy right here, and this regulator pot is on the PCB itself. Okay? It's actually on the board. So I remember when I first changed these caps, I turned this thing on without the board on. And in doing so, I remember seeing smoke. And I remember hearing crackling, snap, cracking, and popping. And what happened is, this is a 100 volt cap. Okay? And this has unregulated 125, whatever the wall voltage is. It usually raises it up a little bit to about 125. So that had 125 volts across it, and I think it damaged this cap. I think that's why I think we're losing voltage and current to ground through this cap, because I think I kind of shorted it. So I need to replace this cap. What I'm going to do, just to kind of prove that before replacing this, is I've got the original cap right here. And I've tested this cap, and this cap is not shorted. The capacitance is actually right on par where it should be. So just this one lug, the 600 volt lug, or the 600 microfarad lug, I'm going to jump. I'm going to remove this cap. I am going to remove the 600 cap. And then I'm just going to wire in and jump to this cap for that 600 microfarads. And then see if I get what I get. Because I think that's the problem. I'm going to just cut that thing right out and then run some wires from ground to here and from, you know, the positive side to the positive lead on this guy. And we'll be filtering just the 600 microfarads in this cap. So I think that's what happened. I think I damaged the cap. Because I did not realize that the regulation for that B plus power supply is on that board. And I realized that. I didn't think. That's all.
It's why you fail.
So, I mean, yeah. Okay, I blew up that's a pretty expensive cap, I would think, maybe. I don't know, a few bucks anyway. So I'll go ahead, clip that out, run some leads down, wire this guy in, just that one 600 microfarad lead, and see if we get our 30 volts B+. So let me do that. I'll be back. Hi guys, well, I was on the right track about a bad cap. I just had the wrong cap as the bad cap. I've got this guy wired back in, and I do have this cap still, and I tested this guy. This is that 680 at 100. And as you can see, I've got the can wired back in. Well, this cap is good. I tested it out and it was fine. I hooked this up, same thing. So what I did is I clipped this guy. Let me show you. I just went ahead and clipped that one off. That's the one obviously that blew up, because now if I probe, well, here's and I adjusted this to 73 volts, right? So there's our B plus there. And now right here, with the cap clipped, I don't want to short nothing. With the cap clipped, I get, there's my 30 volts, 32 volts, whatever. Yeah. And that's right there at the resistor. So that guy blew up. So I will solder this guy back in, put in a new cap right there, and that should take care of the power. Alright. By the way, now, I don't know if you can hear this. That thing's humming right along, so I can tell this thing has high voltage now. So I will go ahead and do that stuff. Yeah, it was just a power supply issue. I blew up a cap. Do not turn these things on with that board off of it, because you will blow up your cap. So let me go ahead, get this resituated, and you know, go from there. Yeah, you can see this dude popped right out. This thing vented right out. Easy value. easy to replace. I got this guy unhooked, and I did verify with a nice snap that the high voltage is working. So I put the discharged it, and I got a good snap. So this high voltage is working, which is great. So I'll go ahead redo these caps, and yeah, should be looking pretty good, hopefully. Okay, I replaced this cap, and I soldered a new one, a 220 at 50 in, and I didn't have any more like this, so I had to do one like that, and I just soldered it to this kind of ground plane that I had on the ground to ground it. I pulled the board off because I want to go over it and recheck all of the solder joints, make sure someone's already capped this, so that's good. So I just want to verify that all the solder joints are good, and then we'll put it back together. I'm going to reset the 73 volts, and then we'll put a signal to it. Okay, I went through, I resoldered all of the header connectors where the board connects, you know, in these pins. I got my new cap back in. It's all ready to go. I got my meter set up because I am going to set this to 73 volts. That's the B plus on this cap. So I'm going to go ahead and turn it on. And it is on. And it's at 79 volts. So let's turn it down. There we go. Okay. So we're at 72. Let's make sure I want to make sure I still got 30 on this cap, and I do. That's my 30 volts. So this thing should be good to go. So now let's set it up right, and then I'll get my Atari football out and we'll check it out. Right, I got Atari football out. This is my personal Atari football board. I like to have a board to be able to hook up to test various monitors, and this just happens to be my black and white raster board that I use. And this is the monitor that we just fixed. You can see the caps down in there. And everything I did was I reflowed all of the solder on the board. I tied that flyback down because it was just dangling. So I tied it down. I replaced the TO3 socket on that guy and put a new insulator and all that good stuff down. I tested all of the transistors. They were all good. New filter caps. We set the B plus proper. And I guess that's about it. But it looks beautiful. I mean, beautiful. Yeah, that's going to do it for this one, guys. As always, I appreciate it. Little black and white monitor repair, basically a recap, and then having to track down my when I blew that cap up. Yeah. So we did some voltage testing. It was kind of cool, seeing kind of, you know, troubleshooting that fault. That's going to do it. As always, thanks for watching. Don't forget to subscribe and all that good stuff. And yeah, we'll see you on the next one. Getting more into this monitor repair, and I enjoy doing monitor repairs because they're kind of challenging. But yeah, they're not that bad. So, all right. Thanks a lot, guys, and we'll see you on the next one.